Hello and welcome. Today we're going to be looking at Young's modulus. The objectives for this chapter: firstly, we want to define and use the term stress, strain, and Young's modulus. We want to be able to describe an experiment to determine Young's modulus of a metal in the form of a wire. We want to understand that the area under the force extension graph represents the work done. And we want to deduce that the strain energy in a deformed material from the area under the force extension graph. Okay, so word consciousness, a few things that we need to define. Firstly, who is Young? Thomas Young was an English mathematician and physicist, also a physician, best known for his work on Young's modulus and his work on interference, which we'll be doing later, the double slit experiment. Okay, so in this chapter we'll be looking at strain. What is strain? Strain is the extension per unit length produced by tensile or compressive forces. Okay, stress is the force acting per unit cross-sectional area. Young's modulus is the ratio of the stress to strain for a given material resulting from the tensile forces, providing that Hooke's law is obeyed. Strain energy is the potential energy stored in an object when it's deformed elastically, and work done is the product of force and the distance moved in the direction of the force. So firstly, we're going to look at what is strain. So in the previous section, we looked at Hooke's law and how we could determine the stiffness or the spring constant of a spring. But we can also determine the stiffness of a material and compare it to another material. And what we do here is we're looking at Young's modulus. Now, in order to do that, if we speak about metal wires and we want to compare their stiffness, we want to see firstly how much they extend depending on the force or the load that we apply to them, and that will give us an idea of their stiffness, how much they or how easily they expand when a force is applied. Similar to a spring, the more you pull on it, the more it will expand if it's not as stiff. But if it's very stiff, a lot of force is needed to expand it. Okay, so the first thing that we need to look at is the strain, and the strain is the original length over the extension. So this is the setup for Young's experiment. We're going to look at two things that influence and have an influence on the stiffness of the wire, and then we're going to look at Young's modulus. So the first thing that we call is the strain. So to calculate the strain, strain is the extension of the wire over the original length. Okay, and in symbol form X over L. Now, both of these will be measured in meters or centimeters, so strain is just a ratio, or sometimes they ask for the percentage strain when you take the extension over the length times 100. But this is hardly ever seen, or not that often. So strain extension over the original length, and if we go back to our experiment, we see that there is a pointer next to the meter ruler, and that is used to calculate the amount of extension. So we take the whole length of the wire between the load and the clamp, and then we see how much it extends, and that will tell us the extension of the wire when we place a load. Okay, so the next thing that we also have to take into consideration when we're looking at the stiffness of a wire is not just the strain, how much it extends, but also the thickness of the wire compared to the force, and that is what we call stress. So the stress is defined as the force over the cross-sectional area, and here we're going to be looking at the load that we hang on and the thickness of the wire, because the thicker the wire is, the more it's going to affect us. And the strain is then F over A, which is basically the same formula as pressure, in the same unit, Newton per square meter or Pascal. So that means that the strain of the stress is specifically about the thickness of the wire compared to the load, and the stress, The strain is going to be how much it extends.